So, function notation and making predictions. In this section, we will learn a new form of expressing equations. This new form is the function notation. Earlier, we had to use a table, a graph, an equation, and or words to show that we had a function. Now we can use the notation f of x, or f in parentheses x, which is read as f of x. And it's used to represent basically the y. So remember f of x. In few words, y equals f of x. If we have an equation, y equals 3x plus 4, we can write the equation as f of x equals 3x plus 4. Why do we change the notation? Well, this makes it easier to ask questions such as A. What is f at 4? B. Evaluate f at 10. And C. Evaluate f of x when it equals -2. We'll come back to this real quick. Let's go for definition first. Definition. The dependent variable function f can be represented by the expression form by writing the independent variable name within the parentheses of f. So f within the parentheses. So dependent value or variable is the one that's on the outside. And in the parentheses we have the independent variable, or in other words the x. We call the representation function notation. Four-step modeling process. Do notice that even though we can change the function format or the form we state our functions or equations into saying function notation or f of x, well, our four-step modeling process is still the same. We would still, one, create a scattergram of the data to determine whether there is a line that comes close to the data points. If so, we would choose two data points, not necessarily data points, that you can use to find the equation of a linear model. This is the same as before. 2, find an equation of the model, same as before. 3, use a graphing calculator to verify that the graph of your equation comes close to all of the points. And 4, use the equation of your model to make estimates and make predictions and draw conclusions. So once again, this would not change very much. The only thing that we've changed is the fact that we're now saying it's a function format or function notation or f of x. Okay, so let's go back to our statements previously. So in this case, before we used to say y equals 3x plus 4. This would be our general linear equation, y equals mx plus b format. It's still the same. Do be aware of that, okay? Not much change other than how we're stating it. Now using the function notation though, we say f of x equals 3x plus 4. And it still stays the same. On the right side we have the equation, 3x plus 4. On the left side we have the function notation, y equals or f of x. So let's try the first one, problem A. If x equals 4, y equals what? This used to be the old notation of how we would ask questions. But in this case, for A, we're stating that what is f at 4? So therefore f at 4, so notice the x value is in the parentheses. That means in this case we know the x value. Since we know the x value, we're going to plug it in for our x locations. So f at 4 equals 3 times 4 plus 4. That is our x representative, and it gets replaced wherever the x is. So 3 times 4 gives us 12. So 12 plus 4 gives us 16. Do notice, the left side, f at 4, we leave it alone. It's just represented as the function of 4, f at 4. It's the right side that we simplify in this case. So it gives us a total of 16. In the old format notation, if x equals 4, we would say y equals 16. But now we have the question and the answer in the same statement. F at 4 equals 16. B. If x equals 10, then y equals, it looks like we know the x value again. So B format said evaluate f at 10. So f at 10 is the x value. Notice x is represented inside the parentheses. The y value is on the outside. So we're going to substitute the 10 wherever we have an x value. There's our x. We replace it with the 10. So we say 3 times 10 gives us 30. 30 plus 4 gives us 34. So f at 10 equals 34 would be our answer for this new function notation format. Before we would say that f equals 10, y equals 34. But once again, now our answer is f at 10 equals 34. We have the question and the answer. Let's try one more. C. Notice it says evaluate f of x equals negative 2. Well, the x has no value. That's the one in parentheses. So that means in this case, we know the y value instead of the x. So y equals negative 2. So therefore, we are looking for the x value. So if blank equals 3x plus 4 then, we don't have the f of something because it's the y value that takes a negative 2 place, or negative 2 that takes the place of f of x. So now solving. Keep in mind we're replacing the y value with the negative 2. Solving for x, that means we've got to get rid of the 4. It's a positive, so opposite, subtract. Minus 4 from both sides. On the right side, it cancels out. Plus 4 minus 4 cancels out. On the left side, negative 2 minus 4 gives us negative 6. And now we got to get rid of the 3 via division. So we're dividing by 3 on both sides because the 3 is multiplying with the x. 3 divided by 3 cancels out or gives us a 1 technically. Negative 6 divided by 3 gives us 2. Positive divided by a negative or negative divided by positive gives us a negative 2. So notice, in the previous format we would say if y equals negative 2 and we would give our answer as x equals negative 2. It happens to be the same in this case by chance. On the old format, we would say that, but now we can say negative 2 equals x, or we can state the new function notation format, f of negative 2 equals negative 2 in this case. So we have both the x and the y value.